Roger says, Mr. Lawrence here, and I'm about ready to cry. This is the second time I had to make this video. I think the computer just shut down while it was saving, and I didn't realize it. And so I have to redo it, but that's okay. You guys are with it. We've got a test tomorrow. We're going to go over the review sheet problems, and I've got them right here handy. I'm not going to retype them. All right, let's see if I can make them a little bigger for you. Let's see here. Let's go 200%. There we go. That's nice and big. So we'll do the first problem here about Kaboom, the world's topmost demolitions expert, needs to make 600 ounces of a 42% nitroglycerin solution for a wonderful explosion he is planning. Unfortunately, he has only 2 bottles of nitroglycerin. One is 30% nitroglycerin and one is 50% nitroglycerin. How many ounces from each bottle should be mixed to create his necessary mixture? All right, so we know we need 600 ounces. But let's get our chart set up here. And so this will be the bottle 1, not bottle 1. And then bottle 2. And this will be our total. And then we're going to worry about our ounces. We're going to worry about our percent. And remember, with our percent, we're going to use the decimal form of it. And then we're going to need to know the actual ounces that are nitroglycerin. And I don't know, hold on one second. This is kind of strange, but that is the empirical formula for nitroglycerin. You know, like H2O is water. It's probably like C3H5N3O9. I had to look it up, didn't know that off the top of my head. But anyway, I didn't want to write nitroglycerin. I think that was more work to do. Anyway! Ounces from bottle 1. How many ounces are we going to use? I don't know. Bottle 2. How many ounces? I told you I don't know. Total 600. I've got my first equation from things I didn't know. First bottle is 30%. Second bottle is going to be 50%. And the last bottle, the mixture, has to be 42% nitroglycerin. Now all I have to do is multiply down. Right? So I'll get a 0.30x. plus a 0.50y, and then 42%, I want to say it's 252. Like I said, this is the first time, not the first time I did this, but let me just double check. Yeah, 252 is right. How did I get 252? Well, of course, I multiplied down. I multiplied 0.42 times 600, and there we go. Alright, so my two equations are x plus y equals 600 and 0.30x plus 0.50y equals 252. I like to do these by substitution, so I'm going to go ahead and solve. I think I'll solve this equation here for y. For x. I'll solve for y. So I'll subtract x from both sides. And that will tell me that y is going to equal 600 minus x. I'll take this and substitute it in the second equation right there. And I will get 0.30. I think I'm going to run out of room. I better put this down below. Let's see, 0.30x plus 0.50 times y, which is 600 minus x. And then I'll equal 252. All right, I'll get 0.30x plus 300 minus 0.50x. That'll equal 252. All right, I'll combine my like terms, and I'll get a negative 0.20x plus 300. And that'll equal 252. I'll subtract 300 from both sides. And I'll get a negative 0.20x, and that will equal 48, negative 48, right? Okay, so I'll divide by negative 0.20, negative 20 hundredths, or 2/10, all the same number. Okay, and so then x is going to equal a positive number, and so I am going to multiply, let me see here, it's going to be a 0, carry the 4, 240. 240 ounces of the 30% nitroglycerin. Right? Now to get the other one, I know that x plus y equals 600. I'll put 240 in. And I'll subtract 240. And then y will equal 360. So I'll have 360 ounces of the 50% nitroglycerin. And there you go. All right, very good. Let's go on to the next problem. There's my chart all ready to go, but you don't know what the problem is, so we better go ahead and read it. Whole problem. There we go. All right, we're going to do problem number 4. Lorena has a can with 100 nickels and dimes. She has a total of $5.10. How many nickels and dimes does she have? Well, I go to this one. I'm going to have coin 1. Coin 2, the total, right? And then we have the amount or the number of the coins. And then I'm going to have the value, which is the decimal. And then I'm going to have the money from the coins. Okay, well, how many nickels are there? I don't know. Oh, is it nickels and dimes or what is it? I forgot. Nickels and dimes, good. Okay, how many dimes are there? I don't know. How many coins are there? Well, I think it's 100. I've got my first equation. What's the value of a nickel? It's 0.05. The value of a dime, 0.10. What's the value? We don't fill this box in because we don't have a dime or a nickel. Okay, we don't have a coin that's total 100. We have 2 coins that total 100, so we can't put a value here because they're 2 separate coins. So I multiply down, and I get a 0.05n, and I multiply down and get a 0.10d, and then my value is $5.10. So I now have my 2 equations. I know that n plus d equals 100. And 0.05n plus 0.10d equals 510. All right, I am going to solve this one for d, I think. And when I do that, I'm going to get d equals 100 minus n. So I'm going to write 0.05n plus 0.10 times the quantity of 100 minus n equals 5. Alright, gonna distribute 0.05n plus 10 minus 0.10n. That equals 5.1. Combining like terms, I'm going to add negative 0.05n plus 10, and that'll equal 5.1. I'm going to subtract the 10. And I'm going to get a negative 4.9, I believe. And I'm going to divide by a negative 0.05. Negative 0.05. All right, so let me do that division. Divided by 0.05, and I'm going to get 98. So we have 98 nickels. And then for the dimes, it would be dimes is equal to 100 minus the nickels. Well, that must be 2 dimes. All right, very good. One more problem we're going to do a current problem. And let me see here. Let me go to the story. Story, where are you? Okay, is it going to let me draw in there? It's not, but that's okay. Tell you what, I think I'm actually going to capture this. Hold on one second. I love you. Okay, so we have the problem here. Bob travels upstream a distance of 233.75 miles in 4 hours and 15 minutes. Hold the bus! I know I can't use 4 hours and 15 minutes in my calculations, so I'm going to figure out how many hours that is in a decimal. So I'm going to do 15. Now some of you might know this, but in case you don't, 15 over 60 is going to be 0.25. And then I'm going to cross this out. Hey, I missed. Oh no! and I'm going to use 4.25 as my time. Okay, the return trip downstream takes him, I don't know what that on's doing in there. The return trip downstream takes him 3 hours, 30 minutes. Okay, I don't want to use that. Now, I could do 30 divided by 60, but I know 30 minutes is half an hour, so I'm going to use 3.5. So I'm going to use those times, and I actually want you to cross those out and convert them so that you're not making a mistake. So determine the speed of the boat and the speed of the current. Well, I'm going to go upstream first, looks like, right? So I'm going to have the boat minus, upstream is minus, it's slowing me down. Remember, Mitch pushing me through the wall. 0.75, that's my distance divided by my time. Some of you have just been writing the time right here. You can't do that because this is a speed minus a speed. We have to get a speed. And remember, speed is equal to distance divided by time. All right, and then we'll have B plus C, and that will equal, where are we? 233, the distance is the same, 75 hundredths, and this time divided by 3.5 hours. So I'm going to rewrite these equations after I have done that division. And let me see here, do I have my calculator open? I don't believe I do. Hold on one second. So I have my calculator open, and I need to do, oops, 233. I'm getting a little button happy here. 0.75, and I'm going to divide that by 4.25. Right? Are those numbers correct? So let me double check. Yeah, 4 hours 15 minutes. Good. Okay, and so I get 55. So I'm going to write a 55 here. Now I'm going to have a problem with the mouse, and then I'm going to do 233.75. Then I'm going to divide it by 3.5. Oops. And that will get me that ugly decimal. I'm not going to round it. I'm going to put that ugly decimal on. 7857, 7857, 1428. Okay, so 66.78571428, and I recognize this repeating pattern, 1428, and then it's going to go 57 again, and it's going to go 142857 on forever. Okay, so now I'm going to do elimination, and I'm going to get 2b, and that's going to equal this big ugly number 1, 2, 1, and this big long decimal trailing behind. Okay, and then I'm going to just work smart. You see that big long ugly decimal that's there? I'm going to add 55 to it, right? And now I've got that decimal that I wrote down. Don't worry about that 3 being different than my 2. It's just a rounding. And then I'm going to divide it by 2, and I will get the speed of the boat as that number there. And now it's okay to round. I'm at the end of the problem. So the boat is going to equal 60.89 miles per hour. All right. So now I've got to plug this into one of the two equations. I don't think I want to put it in this one. I almost always put it in that one, but I don't want to deal with this big, long, ugly decimal. So I'm going to put it in this equation. I'll just have to remember to divide by a negative. So I'm going to have 60 and 89 hundredths minus c, which is equal to 55. I'm going to subtract this from both sides. And some of you might get bothered by that. We'll just do this problem, and then we'll change the sign. All right, add some zeros there. I'm going to get 9 and 8 and 5, and I think it's that on the nose. So negative of c is going to equal negative 5 and 89 hundredths. And when I divide by negative 1, I'm going to get that c is going to equal 5 and 89 hundredths miles per hour. And there you go. There's 3 problems for you. I'm not really planning on doing anything else. Your quiz tomorrow will have 4 questions on it. 3 will be very vanilla, just like this. 1 will be about the trains, you know, where they're going this, against each other, and you just add the distances together, or add the speeds together. And then 1 will be about, it'll be a little bit less vanilla. Okay, you'll need to get that done in class. You should be able to do it in that amount of time. All right, Mr. Lawrence signing off. Have a good night, everybody.